Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on October 9th, 2025, just yesterday. This paper introduces an unpaired multimodal learner that uses unpaired images, text, and audio to strengthen a single target modality, and it even quantifies an exchange rate, where one image carries about 228 words of information with CLIP, and about 1,034 words with Dino v2 plus OpenLLaMA. The paper is titled, Better Together, Leveraging Unpaired Multimodal Data for Stronger Unimodal Models, and the implications for model training are quite significant. The approach shares weights across modalities, boosts Fisher information about shared factors, and delivers consistent gains on vision and audio tasks, especially in low-shot settings. Also, the authors shared an open-source repo. You will find the UML implementation with vision language and multi-bench setups, scripts for feature extraction and fine-tuning, dataset loaders, support for CLIP, DINOv2, and OpenLLaMA, plus an environment file. Clear commands show how to run few-shot or full data training, results and checkpoints saved to an experiments folder. Alright, the repo details were covered. Figure 1 shows the core idea. One model alternates between images and text while sharing the same weights. The image stack at left feeds an image modeling objective for downstream tasks. The unpaired text panel below drives a language objective, yet both routes pass through shared parameters. The dashed weight sharing path indicates how gradients unify representations. The bar chart at right indicates higher classifier scores when adding unpaired text compared with image only. So, Figure 1 showed the shared weight pipeline. Figure 2 contrasts the data regimes that feed it. Figure 2 presents 3 panels that define paired versus unpaired setups, which clarifies why correspondences are not required. Panel A illustrates paired learning, where each image has a matching text description. Panel B depicts unpaired data with labels, so images and text carry class tags but lack cross-modal matches. Panel C presents fully unpaired data without labels, emphasizing that the method still learns a shared embedding despite no alignments at all. Alright, the previous figure contrasted paired and unpaired data setups. Figure 4 presents the mechanics. The full graphic shows how images and text become patch or token embeddings, which then feed a shared head, so gradients from both sides update the same weights. The left panel illustrates tokenization, producing patch embeddings, and a class or mean embedding for each modality. The right side depicts UML in 2 modes, with self-supervised decoders for reconstruction and a supervised shared classifier for labels. Okay, the previous figure presented the mechanics. Table 1 reports linear probe accuracy gains from adding unpaired text during self-supervised training. Across multi-bench tasks, Mustard rises from about 60 to 63, Mimic goes 55 to 57, and Mosi moves 56 to 58, which signals better fine-grained cues like sarcasm. On standard vision datasets, Oxford Pets climbs to 86, UCF 101 to 81, and DTD to 78.5. So, Table 1 showed accuracy gains in standard settings. Figure 5 presents robustness under distribution shift, with a 16-shot linear probe trained on ImageNet and tested on ImageNet v2, ImageNet Sketch, ImageNet A, and ImageNet R. The blue bars beat the unimodal green bars on every set, with gains of roughly 2 to 15% depending on the shift. These boosts indicate that language-informed features transfer better because the shared head captures class semantics rather than brittle visual cues. So while the previous figure showed robustness, Table 2 reports supervised image classification gains when unpaired text augments images with VIT-S14, Dino v2, and OpenLLaMA 3B. Full fine-tuning improves the average from about 82 to 84, with Stanford cars rising from 79 to 86. Few-shot linear probes climb strongly, with one-shot average moving from 46 to 51 and 4-shot from 66 to 69. These boosts are largest on fine-grained sets, which benefit from textual cues. So, while Table 2 showed supervised image gains, Figure 6 focuses on audio. The figure compares audio-only training with adding unpaired images or unpaired text across 1, 2, and 4-shot settings. Results on ImageNet ESC19 show sizable boosts, roughly 8 to 16%, strongest in low shot. Results on ImageNet ESC27 mirror this pattern, with about 5 to 16% improvements, which signals that visual or language semantics sharpen audio representations. Wrapping up, 2 takeaways stand out. Unpaired multimodal training with shared weights measurably strengthens unimodal models, especially in low-shot regimes and under distribution shift, and the theory explains why, showing extra Fisher information and a meaningful exchange rate between images and words. The broader implication is cheaper, more flexible pre-training across modalities. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.